Hi, my name is Bryce, and this is Lab 1 about constant velocity. This lab was comparing actual motion and then predicted motion of an object that is supposed to be assuming no net forces and moving at constant velocity, so zero acceleration. The ball was the system, and everything else was the surroundings, and we were assuming that everything it wasn't that we were assuming there was no forces, it was no net force, so like all the forces added up to zero. The initial position, what we started at, that I set for tracker was 0, 0, 0 meters, and then initial velocity was calculated using a position one timestamp forward, and then you just do uh, that position that we calculated minus this position right here to get that velocity in meters per second. Lab uses Newton's second law to predict the final velocity, and because we assumed that F net was zero, that meant that this whole term became zero, and so the final velocity was just the same as the initial, which meant it never changed. However, the final position, was updated using this. So each time it was these numbers were the same each time, and then you just multiplied it by the change in time, which was always increasing. And so the final velocity constantly increased. So the comparison was made using this tracker, and as you can see, the ball moved in the positive x direction. Didn't stay exactly on the x-axis because of the surface that I was using. And this, notice how I didn't start at the very beginning as soon as it was released because it was accelerating at the very beginning, and then I stopped it early, cut the video early because it's decelerating at the very end. So I tried to see if I could get it where it would be at like a constant velocity. And so this was the data. Oh, and then glow script. Like I said, I set the F net. So like we assume no net forces. This is how long my tracker recorded, and then the variable ball.vel was updated each time using this. And because F net was zero, we showed algebraically that the velocity wouldn't change. And so each time it updated, it would just update itself the same while the time was less than 2.02 seconds. And then the position would constantly change using the ball.vel and then the change in time. And this is what showed. The model was a perfect linear line, and then the experimental was pretty close to it. And then as time went on, the ball probably began decelerating because of, we were assuming no net forces, but there was net forces, so there was some error, and the ball kind of moved forward as well. If you looked at the video, you can see kind of at the end where the ball shifted instead of being on the x-axis, it kind of moved below, which could have also affected the velocity. So that's why this discrepancy increases as you go more, like as you increase time. However, the model was pretty accurate. This is what GlowScript would show, and it's basically the same thing, starting at the x-axis and then moving forward in time. And so the position constantly increased, and the velocity was the same throughout. If I had done it instead of going this direction, and I did the ball going this direction, in this direction, it would have it would have started at zero, but it would have been a constant line this way. However, the velocity would have stayed the same throughout. That would have never changed. Tracker wasn't as accurate as the experimental because we couldn't technically assume, like, there wasn't actually zero net forces. And so Newton's second law would be, it's a law, so it would have been more accurate to use this